Across the coastal plain of Brittany, France, more than 3,000 standing stones stretch over 4 kilometers of terrain. For decades, the site was defined by a specific interpretation, the theory that Carnac was laid out according to a precise, continent-wide geometric grid. This theory claimed the stones functioned as a massive observatory for tracking the moon's movements, built using a standardized megalithic yard. However, the physical reality presents a problem. The density and organic irregularity of these 3,000 stones suggests a much more complex history. The mismatch between Tom's mathematical theory and the physical stones transformed Carnac into a crucible for testing modern archaeological data science. Solving this puzzle required a revolution in methodology, beginning with the application of rigorous statistical null hypothesis testing. This was followed by advanced geographic information systems modeling, designed to map out the region's incredibly subtle, undulating topography. Finally, researchers applied Bayesian radiocarbon modeling to microscopic deposits of charcoal found deep within the stone foundation pits. Finding the actual logic behind Carnac requires looking past the search for a celestial master plan and analyzing the localized data of the people who actually lived here. The centerpiece of this landscape is the Grand Menhir Brisé. Before it fell, this single piece of granite stood 20 meters tall and weighed 330 tons. Tom hypothesized that this stone served as a universal foresight, specifically designed to track the 18.6-year lunar standstill cycle. The theory relied on observers standing at 8 specific backsite positions across the landscape to watch the moon rise or set behind the menhir. But this approach falls victim to the multiple comparison problem. When a landscape is saturated with thousands of potential markers, searching for specific alignments guarantees that you will find them purely by chance. This chart shows how a Monte Carlo simulation establishes a random alignment baseline. By scattering thousands of random points across a map, we see that random lines will inevitably hit lunar targets through pure probability. When tested against this random baseline, Tom's lunar alignments fail to exceed statistical noise. Aubrey Burrell applied similar rigor to the megalithic yard, finding that measurement units varied so much by region that the idea of a universal standard could not be sustained. The astronomical data that survives this testing is much simpler, the broad alignments of the midwinter sunset and midsummer sunrise. These verified solar orientations fit into a regional tradition of solstice architecture, also seen in Irish passage graves like Newgrange. The statistics suggest the builders invested their labor into marking the broad, agriculturally vital turning of the solar year, not microscopic lunar astronomy. While spatial statistics cleared the air, the problem of time remained. The acidic regional soils destroy organic bone, making traditional dating methods difficult to verify. During the Neosea project at La Plasker, archaeologists targeted microscopic charcoal found within the foundation pits where the stones were first erected. This chart shows how traditional radiocarbon dating produces wide, overlapping error bars. These spans are often too imprecise for mapping a site's specific construction history. To refine this data, researchers turned to Bayesian statistical modeling to narrow down the probability. Applying this filter to Carnac causes the wide error bars to shrink, compressing the timeline into a sharp probability peak between 4600 and 4300 BC. This reveals that the alignments were constructed and modified organically over a 300-year window. The physical evidence supports this, with standing stones built directly next to functional hearths and cooking pits used by the workers. This multi-generational timeline contradicts the idea of a single architect laying down a unified geometric grid. Carnac was an accumulative landscape, a border or threshold built over centuries by independent farming communities. If a grand astronomical plan didn't dictate stone placement, researchers looked to the terrain itself, starting with basic metrics like slope and elevation. But standard topographic mapping shows no statistical correlation with where the monuments are located. This digital elevation model is part of a methodology developed by Corinne Ruffley to identify the subtle landform shapes that basic maps miss. This required calculating profile curvature, how the slope changes, and plan curvature, the change in the land's aspect. This bar chart shows the result. Monuments are overwhelmingly placed on specific convex landforms, such as promontories. To find out why, researchers used viewsheds to quantify exactly what can be seen from any specific coordinate. The viewshed data shows a clear contrast. Earthen long mounds were positioned to maximize their immediate local visibility. Passage graves were built in locations that command massive distant views, yet they were designed to disappear from sight as you approach them. This is topographic phenomenology, the concept that monument placement was governed by the physical visual experience of a human walking the terrain. These stones manipulate local sightlines and approach angles through a highly calculated use of the physical terrain. These three streams of data, statistical, chronological, and spatial, provide a new model of the Carnac builders. We see a landscape built and modified over 300 years by farming communities who lived and worked on this plain. Their monuments were placed to control how the terrain was viewed and experienced, rather than to fit a continental geometric grid. Their astronomical focus was broad, marking ritual solar solstices that anchored their calendar. The focus on lost ancient calculators often overlooks the actual ingenuity required to engineer a landscape physically. Moving from a top-down search for patterns to a bottom-up analysis of the evidence allowed the real history of the site to emerge. The Carnac alignment served as the primary site that forced landscape archaeology and spatial statistics to mature into rigorous sciences. Real discovery comes from developing the statistical and spatial tools required to measure the reality that ancient people actually inhabited.